Hi everyone, and welcome to our project of computational sociology. We are Group 3, and we are here to present the insights gained and the models we have built surrounding the income of the population of USA, categorized on the basis of a number of factors. The data which we'll be using for this project is survey data extracted from the current population surveys conducted by the US Census Bureau. This data has been made available by UCI on their machine learning repository, and we have divided the project into two parts. In the first part, we would be trying to gain various insights from the data while answering certain questions, and in the second part, we'll take a look at a couple of models that we have worked on based on this data.
So here we'll be discussing the effects of marital status on the average hourly wage. So first thing to notice is that age can be a compounding factor which might affect our results, as it's quite obvious that people who are married will in general have a higher age than the people who are unmarried, and consequently they'll have a greater experience, which suggests that the wage per hour will be higher for them. So to take care of this factor, we need to consider people within a smaller age window such that it restricts this confounding factor, but it still preserves the variability in our feature of interest, that is the marital status. So, after a lot of trial and error, the age window we decided is 25 to 30 years. Next, we had different marital status possible as per the dataset, like widow, never married, married to civilian spouse, etc. etc. And we grouped them into four categories as male, female, clubbed with the married, unmarried to simplify our analysis. So here in the graph, we can see that on x-axis we have different occupations, and on y-axis we have the income values per hour for different status values of marriage and gender. We see that the protective services rendered uh, the protective services basically render the most income, and the farming, forestry, and fishing services render the least income. And for the different marital status possible across all occupations, we see that surprising fact that unmarried female have the highest average wage per hour, followed by the married male. After checking if there's a definite change of pay after marriage, we realized that there is no common trend which can be seen across all the occupations. So, however, did notice some of the interesting trends in a few occupations. For example, in the machine assembling jobs, salaries of women seem to decrease after marriage, whereas male income is on an upward trend, and a similar trend is seen in jobs requiring professional specialty and protective services. So there are some occupations where the income decreases from both males and females after marriage. So no definite reasoning could be found for that.
So, you might have usually heard of this belief that in general males are paid more than females for the same job. So, this is what we'll try to explore in this section. So, we'll try to see if some form of difference exists between the salaries of males and females, and this is referred to as the gender pay gap. Now, even though people usually use this term in a general sense, a pay gap, if it exists, would make sense if you're looking at people having the same occupation, right, or having the same job. So, comparing between two different occupations or jobs wouldn't make much sense, as a lot more variables come into play here apart from gender. So, that is what we have done. We are looking at each occupation, and so you can see what we observed over here. And as evident, the general idea that males are paid more than females always is not, clearly not accurate. It really depends on the type of occupation. So, in the figure, if you see, a positive pay gap denotes that males are paid more in that particular occupation and vice versa. So you can see how lopsided the figure is. So jobs that require technical skills along with the significant amount of physical labor usually prefer giving more salaries to males, as you can see. So this job over here, machine operators, and you can see they prefer males over females, whereas jobs which require precision or managerial roles prefer giving more salaries to the females. So A potential reason for this might be how the jobs used to have a gender tag assigned to them in older times. And although this has reduced now, a certain residues of the system are still visible and thus leading to such disparities. And to further see this effect, what we did was we tried to fix a particular occupation, and we saw if there's any trend according to the education of any person in that occupation. So although most occupations did not show any common trend, some of them, like sales, let's say, or managerial roles, clearly shows that females are paid much more in such category of jobs, no matter their level of education. And you can also see an interesting trend over here, like if you are looking at machine operators and or assemblers, you can see that females with the master's degree are paid a lot more than men. However, females with all other levels of education are paid less than men. So this kind of concludes that yes, pay gaps exist, but it's not unidirectional. It is in some way, it depends on the occupation.
So another interesting trend to notice would be to see how average hourly income of people varies across the country based on the location of their residence. So for this, we divide the country into states to analyze further. So from the map, what we get is that there are rather huge differences in income across the state boundaries. So we can see the yellow area that highlights alone, which is the state of Virginia with the highest wage per hour of 135, nearly 135, with the next highest state, which is Kansas, which is nearly 95 wage per hour. So a difference of nearly 40, as we can see. The lowest state was that of Idaho. On searching, we found out that this state is majorly comprised of rocky and barren areas with very few population and occupations such as fishing and rafting, which don't render a huge income as most popular were the most popular occupations. So, in contrast to that, in Virginia, we had quite high population, which could be one of the factors accounting to this difference along with others. So average income is relatively high in the central parts, whereas south and northern regions show relatively lower income. Notice that one would expect states like California to show higher income if you look at today's data, but since the data we are using is relatively older, so it does not capture the software boom that has occurred. And secondly, the survey was conducted among a stratified sample to reduce the bias. So we cannot take this as representative of today's scenario, but according to the data we had and the timeline, this is what it reflects.
Hi, in this section, we will discuss the effects of occupation on economy. Although not many discoveries can be made from this topic, looking at the insights for income based on occupation is also important for someone who wants to analyze the economy. As you can clearly see in the plot, the insights given from here are nothing unusual. They align with what we would expect without common sense. Jobs requiring skills or relatively higher levels of education like technical support, production, machine operations, etc., offer more hourly pay as compared to primary occupations like farming. Notice that one would expect sales to have relatively higher position on the graph. However, after a little search on the internet, it turns out that majority earnings in sales comes via commission, and this commission is not counted under the hourly pay, and thus sales comes at a relatively lower position in our bar graph.
Unemployment is a very serious social problem, hence, it is necessary to analyze the same. Of the sample that we have, nearly 97% of the people are employed. Of the remaining 3%, we have the following statistics. So, these numbers that you see are out of a sample of nearly 3 lakh people. Majority of the people being unemployed are the ones who took a brief break from their career. A significant amount of people are those who have been laid off. There seem to be a lot of people in the group that have lost their job due to other reasons, but no other finer details were available about the same. A few people belong to the group who have just finished the education and are looking to kickstart their career. So these are the new entrants that you see in this figure. And we were further intrigued to know what education levels do these unemployed people possess. And this is what we found out. A very interesting discovery was made that most of the people unemployed belong to the category of high school graduates or people who have been to college but couldn't procure a degree. You would usually expect that unemployed people would have significantly lower levels of education, right? But after going through some articles, it turns out that high school graduates and the people who have been through college with no degree usually have higher standards for a job. So, because of this, they pass on the jobs which have lower benefits according to them. Whereas people with lower levels of education settle for jobs with lower benefits as well, because of which their unemployment level is relatively low. So, also from this figure, we can see that people with the highest levels of education over here show the lowest levels of unemployment as expected.
In this section, we are analyzing the pay gap between migrants and natives. To create a fair analysis, we decided to compute the pay gap separately for each job code, as different jobs have different variables and give different salaries. As you can see in the graph, we can conclude that for almost all employment fields except managerial positions, natives are paid more than migrants. Then we analyzed each job on the basis of education levels separately. In this slide, plots of cleaners and machine operators are mentioned. Machine operators require more skill than cleaners. In the first graph, natives are being paid more for all education levels except very low educations like less than fifth grade. In the second graph, which is a skill job, there is a one big bar showing more income for migrants than natives for master degree. One point we should mention while talking about education is the high level of education, college and school dropouts among Latinos. They form a large section of immigrants in the US population and have relatively lower education than natives, which hence influence their pay in the skilled jobs, which explains relative decrease in the pay gap in skilled jobs as education level increases.
Hello everyone, I am Debarsho Sannyasi, a final year undergraduate student in the Department of Computer Science and Engineering at IIT Kanpur. Today, I am going to explain few details about the data we have, the training data and the test data, the machine learning model which we have used in our project, and some important test results. So, let's move on. So the training data we have, the number of data points in the training data is around 2 lakh, out of which around 12.3 thousand are those data points which have greater than $50,000 as yearly salary, and the rest of the data points have less than $50,000 as their yearly salary. The test data we have contains around 1 lakh data points, out of which around 6.2 thousand have salary greater than $50,000 per year, and the rest have less than $50,000 per year. So, as we can see, it is a highly imbalanced data set, and so the metrics which will be used to indicate the performance of our model will be the ROC AUC score and the PR AUC score rather than the accuracy, because this is a highly imbalanced data set. Moving on. So, how are the attributes of our dataset look like? So, in total, there are 39 attributes, out of which 7 are continuous, and the rest 32 are categorical. So, the continuous attributes are like age, wage per hour, weeks worked in year, or the dividends from stocks that particular person gets, etc. And the rest are all categorical attributes such as education, sex, occupation code, industry code, country of birth, what's the migration status, etc. So, first of all, implemented our uh, implemented our model in this particular link. So one can go to this link in the Google Colab link and can see the complete implementation. So currently we have a binary classification problem. So we are given the 39 attributes of a person and we want to predict whether that person's income is greater than $50,000 per year or less than $50,000 per year. Greater than $50,000 per year is the class 1, and the less than $50,000 per year is the class 0. So we have used light GBM model, which is a gradient boosting tree framework which uses tree based learning algorithms for our binary classification problem. So in order to use the categorical features or the categorical attributes in our model, we first need to pre-process them. So we convert each categorical feature into its one hot encoding form. For example, let's say country is one of the categorical feature. We convert this particular attribute into a one hot encodings. So for let's say for this particular record with ID 1, which has country as India, so only the country India column will be 1, and the rest all the columns will be 0 for this particular record. And in this way, we do it for all the records for present in our training dataset and test dataset, as well as we do it for each of the categorical attribute we have in our dataset. So moving on, so this is the pre-processing step we need to do before applying our machine learning model, which is the light GBM model. So we applied our light GBM model, and we trained our model using the training dataset, and we tested our performance on the test dataset. And here are some important test results. So overall test accuracy was around 86%, and the ROC with ROC AUC score of 0.93 and PR AUC score of 0.55. The optimal hyperparameters of the light GBM model were computed and decided using k-fold cross validation. So around 20% of the data in the training dataset is used as validation data. And here are some optimal hyperparameters we got after doing the k-fold cross validation. Uh, and Here the reg alpha is 20, the n estimators is 350, and the learning rate is 0.08. And here are the class-wise test results, where the precision and recall were computed using the default threshold value of zero point 0.5. Here you can see the test results class-wise. And lastly, here are the AUC, ROC, uh, ROC, AUC, and PRAUC curves.
Hello everyone, I'm Aman Verma. I'm a final year undergraduate student at IIT Kanpur pursuing my majors in electrical engineering. Today I'm going to explain various features and their importances in the US Census data. So in this part, we have tried to capture the importance of various features and attributes in our data which are directly or highly correlated with the income. So as you can see in this table on the left, we have listed down various attributes along with their importance for having a paycheck of greater than $50,000. So as you can see in this table, we have age as a feature which has 15.18% importance, whereas we have hours per week feature which has 8.27% importance. So when we see this in a graphical mode, we can infer various conclusions directly. So, uh, as we can see that age has 15.18% importance. So this is also quite expected as experienced individuals tend to get paid highly than a new graduate. Along with that, we can also see that education has a substantial impact on getting a huge paycheck. It has 11.92% importance, whereas the the features such as native country are not too much directly related to getting a huge paycheck, as their importance is being labeled as 1.86 by our model. So these data driven insights can be used to make decisions which would lead an individual to get a better salary